Hello everyone. Yeah, again continuing with my 6 computer study test challenge by Harsh Koel. So in this video, I'm going to solve scheduling a course problem. So let us take a look at it. So the problem statement is there are total of num courses. I mean there is a there are these many courses labeled from 0 to num courses minus 1. You are given an array of prerequisites where AI denotes the course which you like prerequisites I denotes AI comma BI, which indicates that course BI have to be taken first if you have to complete AI. So for example, if 0 1, so you have to complete 1 before completing 0. So in that relation we have to determine whether we can finish all courses or not. So yeah, like as you can see, the example cases 1 comma 0. For doing 1 we have to finish, we have to complete 0th course. So as there is no restriction for the 0th course, we can complete 0 and 1 as well, so we can complete the courses here. But for the second example, it's not like that. For completing 1 you have to complete 0, and for completing 0 it's 1. So as you can see, when we connect these points, they'll be forming a loop, right? So if we closely observe, if we connect the pairs in a graph like structure, we need to just find if there exists any loop in it or any cycle in this graph. But we have to take that in mind as well, that the graph will be a directed graph here, not a simple graph, because it will be indicated like for completing 0 you need to complete 1. That's the primary case we have here. So the question simply solves into detecting a cycle in a directed graph. So for that we can use simple DFS and a DFS visited array. I'll show you how. I mean, it's simple when I write it in code. So let's take n equal to num courses. Okay, right. So let me take adjacency list of an array of n vectors. I mean an array of data type vector, right? So we need to map these prerequisites, right? Spelling quite, I'm pretty bad at writing spellings. So yeah, we'll be adding the pairs. So for this request, the first we need to push back in our adjacency list, right? Okay, and after that we need to declare two vectors, one for normal visiting and another one for DFS visited. Why we are taking two vectors is because we need to determine whether in the same DFS course is the same node visiting twice. I mean, if we are if the node is visited I mean in the visited array, if the node is visited, and if we look at the DFS visited, I mean in the same DFS iteration, if the node gets visited again, you'll have to return a true there. I mean a loop exists there, because in a directory graph, uh, visiting the same node doesn't really mean you are visiting it again. I mean, the same node, there can be two paths for reaching the same node. For example, like, uh, let us use paint here. So, there are three nodes, and suppose this is the directory graph, three nodes. So, if I take the adjacency list of 1, it will be 3, right? And 2, it will be 3 again, and 3, it will be nothing, right? So if we calculate DFS for the adjacency list of 1, like if you go check for 1, we'll go for 2 and mark this as visited, and if you go for 2, we check this one, mark this as visited, and we go for 3, right, as the adjacency list denotes, it will be visited, and we check for 3 adjacent parent childs, there are none, so this recursion goes back to 2, there are no other child, it goes back to 1, and again you can see from 1 you're again visiting 3, but it doesn't make it a loop here, no, right? It just, there are two different paths for reaching a node, so it doesn't give you the clarity here of whether the loop is whether the graph is having a loop here. So for that purpose, we will be using a DFS visited array, in which we'll be storing whether in that same DFS iteration, is the node getting visited twice. So in this array vector, we'll be determining that, we'll be storing that information. So for that purpose, we'll be needing this. So we'll get clarity in words rather than just speaking yeah. So initially we'll be checking in, like, if the node is visited or not. If it is not visited, then only we can go. If it is visited, then we don't need to check, right? So if it is visited, if it is visited, then we'll check for the DFS. We'll write this DFS function. We'll pass the which node is visited now, and visited array, and the DFS visited array, and we'll pass the adjacency list as well, right? And if the loop exists here, then we need to return false, otherwise we're going to return true. So let us write the DFS function we're talking about. So it will return a boolean, and let's take I, the ith node value, and a vector of visited, and a vector vector which is for DFS visited, and array of vectors, we can tell like that, right? Yeah. So first, initially we need to make both the arrays as visited, because we're visiting, right? We are visiting that current array, but when we go back, when we like initially, let us make both as visited. And we need to check for its adjacents, right? Like for okay, auto j and adjacent of I if the adjacent member is not visited, I mean if it is 0, then we'll be running our DFS loop there by passing j as my node. Right, and if that comes out to be true, then we need to return true, because that means there is a loop existing there. And else, if the DFS visited is visited again, and I mean in the same DFS location, and I mean if the node is also visited and in the DFS visited iteration is also visited, I mean it is occurring twice, then we need to return true here as well. So here we write the important step. Here we declare as unvisited. Why are we making this step? Because we are making sure that it is not getting repeated in the same DFS iteration. So as in this, so after coming here, while going back, I am making 3 as unvisited. If I have this column, sorry, okay, let us make a new column. So initially 1 was visited, so we'll make it as 1, 2 was visited, we'll make it as 1, 3 was visited, we'll make it as 1. After getting to 3, there are no adjacent bins, so it will go back. So while going back, we'll be making this as, this is the DFS visited array, so we'll be making this as 0, because we don't want it to get visited in the same iteration. So we are going back to the recursion call. We'll be making this as 0, and again we'll be making this 2 as 0 as well. And from 1 we are not making the 0 because there is 3, I mean 2 comma 3 is there, right? So we'll be going to 3, so 3 is not visited, so it will again 1. So in this way we will be not getting loop existing by our algorithms. This step determines that the DFS iteration is done and we can make it unvisited. And at the end we need to return false if we don't find any cycle. So I guess that's pretty lengthy video I had made, but I need to write it down. Okay, wait. Okay, so there was some small mistakes. Prerequisite. this. Okay, fine. Let's giving me wrong answers. And let's see, 1001. Okay, so if let us look at this function. Maybe this is let's write it properly this time. Because it should run now. Sorry. Yeah, so I guess C++ doesn't work in that way which I have written. So make sure you write your commands in this curly braces. So I thought for nested if you don't need this brackets, but pardon me, you require these. Okay, I'm submitting my code. So well, it passed every test case. So the important thing here would like to discuss here is this DFS visited array. Normally for the undirected graph, we don't need this vector because whenever we find any visited node like this, for example, we'll be just returning true, and otherwise there's nothing we can do, right? So that is the only difference. But when this vector determines whether in the same in the same DFS iteration whether we are finding the node visiting again. So for that case we need this. So I hope you get more a better intuition by watching this video. I know it was lengthy and was pretty clumsy in between that paint and all, but I hope you get it. If you don't understand, you can just refer my GitHub repo. It's available. Okay, so it's available in the description link. The link is available in the description, so you can just follow that. And that was pretty good question actually. To be, I got to learn this. I was trying to find cycle detection before, so I was trying it, but I didn't know this method, so I got to know this. So it was interesting to solve this question, and I learned a lot. So yeah, thank you.